Okay, we continue our class today. So we have discussed about the operation of generator on infinite bus yesterday. So today we will move to methods of control, voltage control. Okay, we want to control the voltage and concurrently we will control the reactive power also. So number one is we inject the reactive power. I think this one you have learned in EPS. Okay, this one you have learned EPS when you do the power factor correction, right? Okay, injection of reactive power. And then hello. Oh, yeah. Yeah. Yes, subhanallah, subhanallah dengan ini, subhanallah yang azim tu. Subhanallah yang azim. Assalamualaikum warahmatullahi wabarakatuh. Ada baca subhanallah tidak? Subhanallah tidak. Subhanallah, subhanallah tidak. Subhanallah Allahu akbar. Okey tak? Nabi ajar itu. Boleh. Berarti mengatakan semua urusan terbukti dan juga okey. Sudah sampai masa Okay, sorry. So we have learned about injection of reactive power. This one we look at in detail later. But you have learned some of them in the EPS. And then we will look at the tap changing transformer. So normally when the question in final exam will be emerge. Okay, normally the tap changing transformer, you need to calculate the tap changing transformer, tap setting. Okay, and then use of fact devices. So I think this one I will not touch in details, but maybe in the general. Because I think you will learn in the Abu HVDC and fact. Okay, so let's look at one by one. Number one is injection of reactive power. What we can do with the system when we want to improve something. The first thing is we want to improve the voltage. Okay, so the method of injection reactive power is number one is use of shunt capacitor and reactors, use of static series capacitors, and use synchronous compensators. Alhamdulillah. Sorry. Okay, shunt capacitor and reactors. So why we need to use these components? Number one, we use shunt capacitor and reactors is used for lagging power factor circuits. Okay, so shunt capacitor are used for lagging power factor. And it is connected directly to a bus bar or at the tertiary winding of the main transformer. Okay, so this is due to lagging power factor. When we have a lagging power factor circuits, so we want to improve from the lagging power factor to unity power factor. Let's say your power factor is 0.8 power factor lagging. So you want to improve from 0.8 to 1 per unit, or we call it unity power factor. Remember? So you can install or you can put a shunt capacitor at the end of the bus bar directly, or at the tertiary winding of the main transformer. Okay, this is due to we supply the reactive parts or reactive valves that required by the loads, so that the reactive transmitted over the line are reduced. Okay, and you remember when we learn about the power system analysis, right? So uh, normally when we have a slack generator, right? Or we have generators. Okay, for real parts, normally your generators will be supplied to the bus for the real parts or real power. Okay, we have generators, your real P plus JQ, right? So P is normally supplying uh to the system. This one is maybe it's your bus bar and so on to connect it with the other bus. Okay, so normally your P is positive because it's a real parts. But when we say about the reactive power, sometimes your reactive power is positive, sometimes it's negative. So sometimes when your reactive element in the system is exceed the required one that is required by the loads, so it becomes negative, that can be absorbed by the generator. So negative meaning that the generators is absorb the reactive elements. Okay, so that's why sometimes you need to put capacitor in the bus in order to supply when the situation there is not enough reactive elements in the system. So when you support the reactive elements, okay, normally we make your system as close to the unity power factor. You remember, right, the figures of the triangular. This is your S, this is your P, this is your Q. You have the theta here. Okay, you want to make sure that your Q is because when you inject the generator Q, so you can reduce when you inject the capacitor, you can reduce the Q values. So that's why your S is as close to the P, or your P is as close to the S, because this one is more to zero. Okay. Okay, and then shunt reactors used for leading power factor. So you need to make sure that your capacitor not injected more than is required, because when it's more than the system's required, you make your system leading power factor. But when the leading power factor circuits happen, so shunt reactors is used due to sometimes when it's the lightly load cables. Okay, because your load is very light, so make the system become under load. So it will connected across the load to absorb the leading valve. So remember, so the shunt capacitors connect directly at the bus bar or the tertiary winding. Shunt reactors across the load. So you have load, so we put the shunt reactors, okay, to absorb the leading valves. Okay, the advantage is to make sure that to improve the power factor. For the disadvantage of shunt capacitor and reactors is when the voltage falls, valve also falls, thus effectiveness falls. So this is the problem when we use the shunt capacitor and shunt reactors. On light loads, the voltage increases, the capacitor output is very large, and the voltage tend to rise to SSC level. Okay, that's why when we have the light loads, normally we didn't put the capacitor, because when the voltage increase, the capacitor output is large. Okay, it energizes the system, so it tend to make the voltage is excessive level, so meaning that your voltage is over voltage. Okay, so thus to stabilize the system, capacitor or cable circuits must be switched out by local overvoltage relay. So that's why you have the protection here. We have the local overvoltage relay. Now we move to the series capacitor. So this is how the series capacitor is being connected. So we have the series capacitor here. It's connected in series with the line conductors in series because the name is series. So this one is sending end. This one is receiving end. It is used to reduce the inductive reactance between the supply point and the load. So this is the phasor diagram. What happens when we have the with the capacitor? Without capacitor, your sending end voltage is very high first, and then the angle of the sending end voltage is also high. Tend to make when the voltage sending end voltage is very high in order to maintain the receiving end voltage. So this make your system also the loss become higher. So when install the capacitor, it will bring down the voltage, sending end voltage, to make sure that it is susceptible or acceptable for the sending receiving voltage to maintain. Okay, so this is the impact of the series capacitor. The disadvantage of series capacitor is high over voltage will result when a short circuit current flows to the capacitor. Yes, because we have, when you learn about the capacitor, it will energize the electromagnetic field, right? When the current, basically this one is to prevent the direct current, but when the AC normally will be shorted, but it will energize the capacitor. So when the short circuit fault happen, so it will becoming the high over voltage will be resulted. Okay, normally we have spark gaps, and then non-linear resistors or other special protective device must be used. Okay, this is the disadvantage of series capacitor. So what happened, meaning that you need to extra cost in order to make sure that your system is stabilized. Okay, this is the relative merits. Just now we just discussed about disadvantage. This is the merits. So the merits of shunt and series capacitors: if the load requirement is small, series capacitors are little used. So with the series capacitors, the reduction on line current is small. So hence the thermal consolidation limit the current. Little advantage is obtained by the shunt compensation should be used. Okay, if the voltage drop is limiting the factor, so the series capacitor are effective. So this one how you want to use, whether the perfect example to use, whether to use shunt capacitor or series capacitor. Okay, so if the total reactance is high, the series capacitor are very effective and stability is improved. Okay. We have also the synchronous compensator. What is synchronous compensator? Basically, it's a motor without a mechanical load. Okay, this is an example how we have the synchronous compensator. So this one, but this is how we want to control the voltage, maintain the voltage. Never mind, we skip this one. Okay, this one you can you can read by yourself. Advantage synchronous compensator and the disadvantage. Okay, one of them is the very high installation cost because it requires a large motor. Okay, we have motor here, right? Okay, and then we move to tape changing transformer. Okay. Okay, tape changing transformer. Basically, one of the concept or one of the technique to control the voltage. So when we say about the control the voltage, it is also control the reactive power. Okay, so what is tape changing transformer? Tape changing transformer by changing the transformer ratio. So tape changing transformer have a ratio. Okay, the voltage secondary circuit is varied and voltage control is obtained. The most popular and spread from the control all voltage level. That's why when you learn about Normally we have the from the generator we use a step up transformer, right? So we can control the voltage. That's why you have, let's say we have a generator, the bus, and then you have the transformer with transmission line, right? And then we have the another transformer for the loads. This one for step up, like let's say 11 kV to 22 kV or 220 kV. So this line is 220 kV, and then we use the similar transformer. So it will step down back to the 11 kV. Okay, so this is the most popular and widespread form of voltage control at voltage level. So, but how we want to control the transformer, we use the tap changing transformer. So this is the example. Wait, so you can refer with the module. Okay, in general, tap changing transformer can be described as follow: transform electricity energy from one voltage level to another. Interesting. Comment. Okay, to transform the electric energy from one level, voltage level to another. So basic operation by controlling the secondary voltage. Okay. Then changing the transformation ratio in the secondary circuit. So taps for ratio control. Widespread use for controlling voltage at all level. So we have two types of tap changing transformer. We have off-load tap changing transformer, and we have on-load tap changing transformer. They do not control the voltage by regulating the flow of reactive valve by changing transformer ratio. Tap changing transformer operation is motor operated in radial line. Maintain voltage at the secondary terminals or at load terminals within limits. In time line, tap changer can regulate valves substantially, and in network or loop can control the circulating valves. So this is an example of tap changing transformer. So let's say we have this one is our V1, okay, and then this one we have V2. This one is Vs or V sending end voltage, and then we have receiving end voltage, okay, plus minus. Then here we have our plus minus. Okay, so what happened here from this figure, basically we can derive to obtain the Vs as well as Vr, to obtain the transformer tapping. Okay, and normally we know that your transformer, the ratio of Ts and Tr, Ts times Tr must be equals to 1. Ni kena ingat ah. Okay, so that's why when we have this value, we can say that our TS equals to 1 over TR. That's why we want to find one of them, TS or TR, by using this equation. So basically from here we can use the we can use the Kirchhoff, because the current flow here I Z, we have current flow, and then we have the voltage drop here, plus minus. Okay, this one is your voltage drop. So basically it is Vs minus Vd minus Vr equals to 0, right? So Vs minus Vd minus Vr equals to 0. And then we know that Vs equals to, you rearrange the equation, you get Vr plus Vd. Okay, Vr plus Vd, you get your Vs. Where your Vs, basically you need to times with the change, the ratio. Okay, so here, from here we can say that Vs equals to Ts time V1. So you get this value. And then Vr equals to Tr times V2. So this one is your Vr. And your Vd is Iz. Okay, the current flow is Iz. Nampak buang dulu ni. Okay, we have TSV1 equals to TRV2 plus IZ. Right. So from here, and we know that our Iz is equals to delta V. Okay, delta V that we have learned in the previous notes. Okay, the derivation, how we want to derive this one, right? Where your delta V is Ri cos pi plus Xi sin pi. This one, right? Iz is delta V. So dia ialah sama juga dengan, it is equals to Vr cos pi plus Vx sin pi. Okay. So don't take sini just now. So we have Iz equals to delta V, Vr cos pi plus Vx sin pi. Or you can rearrange the name, is Ir cos pi plus Ix sin pi, just referring back to the notes previously. So from here also we can see Ir cos pi is equals to P equals to cos pi, right? Vi cos pi. So when you have I cos pi equals to P P divided by V, right? So P divided sini. So you get P divided by V. So that's why you get Rp over V. Similar with this value. So Q equals to Vi sin pi. So I sin pi equals to Q over Vi sin pi. So Q over V equals to I sin pi. So that's why you get here. So Rp plus Vr plus XQ over Vr. Okay. Then you can find here, because it's here similar, your Vr is equals to Vr. This one is not Vr, not Vr V2 ni V2 ni. There's error here. Okay, because your VR equals to TRV2. So this one. Okay, that's why you rearrange back this equation, you get this value. So Ix is this one, Iz is one. So meaning that this equation become TSV1 equals to TRV2. Ada error lah ni, bukan T, banyak salah ni TR. TRV2 plus RP plus XQ, TRV2. And then when we have here, what we need to do, we change the TR with respect to TS. TR, because we know TR equals to 1. So TR equals to 1 over TS, and then you put here. Okay, so you rearrange the equation, you get this one. You can settlekan lah. Okay, you make this one. We want to cancel this value. We need to times with TRV2, right? So when we times this one with TRV2, all elements need to be times with TRV2. Okay, so that's why you get so TSV1 times TRV2 plus this one TRV2, you get TR square V2 square plus RP plus XQ. So this is, you get this thing, and then you change your TR with the TS, so you rearrange back the equation, so you get this equation. So your make the rearrangement, you get V2 square minus TS square V1 V2 plus RP plus XQ TS square equals to 0. Okay, so we can see here, we can make this equation look like the quadratic function, right? So where this one is your V2 is your X, right? Okay, this one is, we can say that it is look like ax square plus bx plus c equals to 0. Remember when you learn about the quadratic at your secondary school? Ax square plus bx plus c, right? So yang ni you can factorize it, okay? Or you can use the equation, right? X equals to plus minus b square minus 4ac divided by 2a. Tak ingat lah. Bukan ni. X equals to we have square root here, b square minus 4ac, right? This one apa? Negative 2a plus minus 2a. Negative b, right? Ingat tak? Negative b plus minus b square minus 4ac divided by 2a, you get the value. Kan? Ingat tak?
Betul, sir.
Okay, negative b plus minus b square minus 4ac divided by 2a. So here you can see your a is 1. Your b is this value, negative. Your c is this one. Okay, your a is 1. So that's why you get v2 equals to half. Negative b is negative become positive. T square s of v1 plus minus b square minus 4ac, right? So dia ada square root. So kat sini ada square dengan uh, complicated. So you have negative B. Your negative B is, because A is 1, so 1 half kat luar. Okay. Negative B is your, this value is B. Negative B, negative, negative become positive. TS square V1. Okay. This is your B plus minus B square. Since your B is negative, negative square, it become positive, no problem. So you get TS the power of 4 V1 square minus 4. A is 1, C is your RP plus XQ. Okay. And then this T1, the power of 4, don't forget there's a TS, T1, TS, not T1, TS. TS the power of 4, this one we have TS square, right? So TS square, you can make the factorization there, you can get, that's why the answer is become half TS square V1 plus minus, because TS the power of 4 you can factorize square root 2, right? So you can get this one is TS square, TS square. Okay, you can factorize TS square and square root become TS, and then this one is TS square V1 square minus 4 RP plus XQ. Okay, so that's why you get this answer like this. Okay, so this is what happened. So this is the answer. V2 equals to square half TS square V1 plus minus TS square V1 square minus 4 RP plus SQ square root. This one is square root, right? Square root, or the power of half is your square root. Okay, so this is your equation for to get the voltage. So let's take a look at the example. So normally this example will emerge in final exam, and normally student can get full marks. So please you need to do some exercises to familiar with the question. So let's take a look at this example. So we have 132 kilovolts line is fed through 11 kV, step up to 132 kV. Transformer from constant 11 kV supply. At the load end of the line, the voltage reduced by another transformer of the nominal ratio 132 step down to 11 kV. And then the total impedance of the line of transformer at 132 kV is 25 plus J66 ohm. Okay, ohms. Both transformers are equipped with the tap changing facilities, which are arranged so that the product of the two of nominal setting is unity. This one is meaning your TS times TR equals to 1. Okay, this is unity. If the load of the system is 100 megawatts at 0.9 power factor lagging, calculate the settings of the tap changes required to maintain the voltage of the load bus bar at 11 kV. Use base 100 MVA. So meaning that you need to find your TS and TR. Okay. So first you need to sketch, this is your standing end voltage of V1. Okay, you have a tap changing transformer, so you have TS here, and then you have a TR. This is your V1, V2, standing end, receiving end from the transmission line. So this line is 132 kV. So you have Z. Z is given in per unit, in ohms. Okay, and then this is your receiving end, your transformer step down transformer. And then this is your receiving end. Okay, so we know that our V1 and V2 132 kV. So we assume that this is your system is 132 kV. So so we can say that this is rated value. Your rated value is 1 per unit, meaning base is 132 kV. Okay, and then the question is given is 2566 ohm. Before that, you need to look at your load. Your load is 100 megawatts, 0.9 power factor. Okay, so your load is 100 megawatts. Give 0.9 power factor. Cos pi is given. So how you want to find your Q? Okay, so you do what? You inverse the theta, right? So inverse cos 0.9 dapat berapa? You dapat so shift cos 0.9, you got 25.84. So your theta, your pi is 25.84 degrees. Okay, to find your Q, you can use tangent, right? Tangent theta equals to Q over P. Ni S QP, right? So your Q equals to P is 100 megawatts, 100 tangent theta. So you tangentkan you punya result tadi. Shift cos 0.9. Shift cos. So tangent answer darab dengan 100. You get your Q equals to 48.432. Okay. Kan?
Betul.
Tak cuba verify.
Dapat sir. Sama.
Sama sir.
Okay. Tangent 25.84. 484.2. Okay. So bagi dengan 100 lah. So kat sini kalau boleh buat 3 titik perpuluhan lah. Tapi kat sini buat 1 titik perpuluhan ni 484.48. Macam mana 483 ni? Okay, kita ikutlah jawapan dia. So dapat this one 100 plus 48.3. Let's say kita sebab dia bundakan kot. You get 48. 1 plus J 0.483 per unit. This is your load. Okay. And then to get your result here, your Z in per unit, it is Z base lah. Z base equals to kV square divided by MVA, right? So your kV is 132 kV square divided by 100 MVA. So you dapat 174.24 ni. Then you can find your Z in per unit. So it's 25 plus 6 J66 divided by 174. You get 0.14 plus 0.38. Okay. So this is your Z equals to 0.14 plus J 0.38. So this one is your R. This one your X. Okay. So from here we can find our V2. You need to find your V2 by using the equation here. So I think the equation is given. So you no need to memorize. This is your V2 equals half TS square V1 plus minus TS square V1 minus 4 RP plus XQ. Okay, since we know that our V1 and V1 is 1 per unit. Okay. And now we know that our V2 also 1 per unit because it's 132 kV. So the voltage is in terms 1 per unit. So we know our R in per unit 0.14, and then we know our P is 1 per unit. This one, right? Your P, this is your P, this is your Q. And then we know our X, X is 0.38, and our Q 0.48. So you put all the information here, so you get your value. You need to solve this value. So you get TS square over minus this value is 1.28. You can verify the answer. Okay, and then from here you get this one, right? Tu you jarak kat atas kat ni. So and then you bring the value to here. Okay, so you get 2 minus TS square equals to TS square minus 1.28. Ini kan. So ni ada setengah, ada square root. So nak hilangkan square root ni you kena kuasa 2 kan. You kuasa 2 kan, maknanya darab 2. Yang ni pun kena kuasa 2. So you get this value in terms of these terms. Okay, and then you kembangkan balik sampai dapat T, so ada TS kuasa 4 ni dan sebagainya. And then you can get your value. Rearrange and you get one value of TS. So you get two values basically, one positive and one negative. So take the positive one. So your TS is 1.21. From here we can find our TR. 1 because our TR equals to 1. So you can get TR equals to 1 over 1.21. So that's why you get your TR equals to 0.83. The setting. Okay. Boleh kelah? Ada soalan? Is there any question?
Sir,
Yep.
Saya tak faham yang R tu macam mana dapat 0.114
R. R kan dibagi 25, 66 kan?
25 tambah J66.
Ya, ni dalam ohm.
Aha.
Dia kena tukar dalam bentuk per unit lah. So you kena cari Z base. You belajar dekat PSA kan? Nak cari Z base equals to KV square divided by MVA. You kena cari Z base. Z base. Sekarang you punya KV dekat line ni 132 kan? So 132 KV square bagi dengan base kita pakai 100 MVA. Berapa dapat ni?
Dapat 174.24
174.24 ohm. Ni ohm. Z base. So dia bagi 25. So nak cari Z base, nak cari Z dalam per unit. Z dalam per unit 25 plus J66 bagi dengan 174 ni. So ni ohm akan cancel. Dia akan dapat jawapan dalam per unit. Kan? That's why 25 bagi 174. 174.24. You dapat 0.143. That's why dapat 0.143 something lah. So ni contoh yang tak elok. Sebab dia sebenarnya ada, you need to use until 4 decimal lah, 4 decimal points. Jawapan ni 0.143 kan? That's why dapat. This one your R, this one your X. 0.3 something tadi lah.
Okay, dapat.
Okay? Boleh? This is fundamental lah. You kena belajar ni dekat, bukan kat PSA, kat EPS ni belajar. Z base ni. Boleh? Any question? Any other question?
Tak ada, sir.
Tak ada lah. Okay, kalau tak ada, I think that's all. Yang lain ni boleh belajar sendiri lah. Okay. So like I said yesterday, we have quiz right today. Kan? Okay, so we have a quiz lah. Quiz.
Sir,
Yep.
yang apa TS times TR tu kan,
Ah,
memang will always equal to 1 ke sir?
Ya.
Ke sebab dalam soalan ni dia kata dia unity ke
Ya,
sebab
unity ni.
sebab tu lah.
Ya, unity kan satu. Unity
Tapi kalau
kalau unity operator apa?
kalau dia tak mention
Dimension still satu. Biasa type change transformer normally TS darab dengan TR satu.
Okay,
Ratio dia memang macam tu.
Okay.
Okay. Kalau dia tak mention pun TS TR memang satu. TS darab TR sama dengan satu. Boleh? So tak ada, kita buat quiz lah. Final quiz lah. Alhamdulillah. Mana? Saya ambil lah yang dulu ni. Malas tengok, saya cuba buat. Tengok ada tak. Ni quiz. Tengok soalan. Boleh lah ni. Okay, quiz for saya bagi sampai pukul 12 boleh? Boleh tak? Jawapan tak ada. Kelas boleh tak?
Boleh sir, boleh.
Boleh tak?
Kelas.
Boleh.
Ada kelas. Benda ni sebenarnya you boleh buat 10 minit je. Okay lah, saya tambah sampai 12.30. Boleh?
Okay.
Okay lah?
Boleh.
Jangan saya bagi. Saya save as dulu.
Boleh.
Ni ada marker sini. Banyak. Mana? Okay, submit. Oh ni ya, bentar dia dah. Is for 2.5%. Sampai 12.30 boleh ya? Sebab ni boleh buat 10 minit sebenarnya. Okay, di sini. So ada soalan lain? Is there any other questions? Ada soalan?
Tak ada, sir.
Okay, kalau tak ada, we stop here. So apa lagi nak tinggal lah. Kita tengok balik kita punya schedule. Look at our schedule. What we have. Ni lagi. Ni tahun bila ni. So today ada quiz. So assignment lagi 10% lah. Assignment individu lah. You kena buat hand calculation. Soalan-soalan berkenaan dengan real power control. So I will upload later. Assignment. Remember, please make remember ni. Remind me. Okay, so next week we will try. Hari Khamis ada kelas ke? Christmas ni. So next week kita kelas sampai Rabu lah, Khamis cuti. Boleh?
Boleh.
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 So next week kita akan cuba discuss contoh soalan-soalan test dan final exam. So lepas tu 31 tu kita ada test 2. Kau nak test awal? Kalau nak test awal kita buat 30 hari bulan lah ataupun ikut UR.
Test lewat je.
Maintain 31 lah. Before New Year ni. Quiz kita berapa dah? Quiz 4 dah kan? Quiz 4 dah. Quiz 3 ni bila? Quiz 3 saya dah bagi dah kan?
Dah.
Tak ingat lah.
Dah bagi sir.
Dah, so tinggal quiz 4 dengan assignment dengan test. Okay. So test kita maintain lah 31 bulan. So next week kita akan cuba discuss, saya akan bagi assignment dan juga kita akan discuss contoh-contoh soalan selepas. Okay. Kalau tak ada soalan kita stop kat sini. Okay, see you next week. So jaga diri baik-baik. So kita jaga kita. Okay, so please stay at home. Hopefully we can beat the COVID lah. That's all for today. Thank you very much. Assalamualaikum warahmatullahi taala wabarakatuh. Thank you.
Thank you, sir. Waalaikumsalam.